Okay, welcome back. 2017, question 2 with calculator. Again, important, we're in radian mode, seeing that we're dealing with a trig function here, okay? This is the infamous banana problem of the 2017 exam. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by this f function. Okay, so 10 plus 0.8t, sine of t cubed over 100, just some weird looking function, on the interval from 0 to 12, where f of t is measured in pounds per hour, and t is the number of hours after the store has opened. So the store is open for 12 hours. This thing gives the rate at which bananas are being removed at time t. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by this g function, 3 plus 2.4 natural log of quantity t squared plus 2t, on the interval from 3 to 12, where g is measured in pounds per hour and t is the number of hours after the store has opened. In part A, how many pounds of bananas are removed from the display table during the first 2 hours the store is open? So this is similar to one of the calculator problems we saw from the 2018 exam. Okay, if we know the rate at which something's occurring and we want the total amount of change, we integrate that rate of change. So how many pounds of bananas are removed? Well, here's the rate at which they're being removed. Okay. F is the rate at which they're being removed. We want to know how many have been removed in the first 2 hours. So we're simply going to integrate the f function from time 0 to 2. Okay, so for 1 point, you show that integral setup. It's fine if you want to write the whole equation in there, as we've discussed before. Then use your Math 9 feature to carefully punch it in. And to 3 places, we get 20.051 pounds of bananas. So if that's the rate at which they're being removed, over the first 2 hours, just over 20 pounds of bananas have been removed from that display. All right, part B, find f prime of 7. Using correct units, explain the meaning in the context of the problem. So this is also a 2-point problem. You don't really have to work too hard to take the derivative of the f function up there. Okay, keep in mind, this is a calculator problem, and we're evaluating a derivative at a point, at 7 here. So we can use the Math 8 feature. All we have to write is f prime of 7 equals, or is approximately, and then just use your Math 8 feature to punch that in. Okay, you should get about negative 8.120. Okay, so there's 1 point for the value and then 1 point for the meaning. Okay, well, f prime is the rate of change of f. F is in pounds per hour. And if I take the derivative of that with respect to t, I would have pounds per hour per hour. Okay, so what does this mean? Well, it more or less means that at time 7 hours, right, this is the specific moment in time that this has occurred, the rate at which the bananas, think about it like this, f prime is negative. So what is f doing? It's decreasing. So at time 7 hours, the rate at which the bananas are being removed is decreasing by 8.12 pounds per hour every hour. Okay, or something to that effect. All right, we want to be specific to the time when this is occurring, and you got to be specific to the units. The fact that, okay, look, the derivative is negative, so this f function is decreasing at this rate in pounds per hour every hour, pounds per hour squared, however you want to word that. Okay? All right. I'm going to make a little room here, pick up at part C. And is the number of pounds of bananas on the display table increasing or decreasing at time 5? Give a reason for your answer. Okay, so this is the first part where we're now going to introduce this g function, okay? We just want to know, is the overall number of pounds of bananas increasing or decreasing? All right, so if I let, again, A represent the total number of pounds of bananas, at time t hours, right, then I know the overall rate of change for that quantity is the rate in minus the rate out. Now be careful here. G is the rate in. That's the rate at which they're being put back onto the display table. They're adding the bananas to the display table at this rate. So it's going to be the rate in minus the rate at which they're being removed, and that was the F function here. So the overall rate of change for the total number of pounds of bananas is the rate in G minus the rate out F. Okay, so if we want to know if the overall amount of bananas is increasing or decreasing, let's look at this value at time 5. So we're looking at G of 5 minus F of 5. And again, take a moment to very carefully punch that into your calculator, and you should get back approximately negative 2.263. All right. Now, since that value came back negative, what does that tell us about the amount of pounds of bananas? It is decreasing. Since G of 5 minus F of 5 is negative, the number of pounds of bananas on the display table is decreasing at time t equals 5 hours. Okay, so there's that. And then finally for part D here, how many pounds of bananas are on the display table at time 8? So again, if you think about it, here's the rate at which the pounds of bananas are changing. We're going to want to integrate this thing. Again, it's similar to things we saw in the 2018 exam that we've reviewed. I'm going to set this one up a little different, though. Let's think about it this way, okay? So the number of bananas at any moment are going to be the total. It's basically this. It's the number of bananas we began with, right? Plus all the bananas that we've added to the display table over the day, minus all the pounds of bananas that have been taken away, right? So again, at the end of the day, we had what we started with on the display table. We've added a lot over the course of the 8 hours, and we've taken a bunch off over the course of the 8 hours, right? In fact, actually, we haven't even added a bunch over the 8 hours, or the 12 hours. We've only added them from time 3 to 12. They've been removed from time 0 to 12. Okay? So look, here's the deal. So again, just back it up, think about it. It's the amount at time, specific to time 8. So the amount of bananas at time 8. Here's how I'm thinking about it. It's going to be the amount that we started with at time 0, right? And we were told that when the store opened, there were 50 pounds of bananas, right? So we started with 50 pounds of bananas at the beginning of the day. Then, from time 3 to 12, well, in this case, from time 3 to 8, that's the rate at which the employees added pounds of bananas, right? So we want to account for the total number of bananas that were added from time 3 to 8. So we had what we started with at time 0 plus the total number that we added from time 3 to 8. And so we would integrate the G function from time 3 to 8 to get that total amount that were added. Then what we want to do is we want to subtract all the pounds of bananas that were removed from time 0 to time 8. So we're going to integrate from time 0 to 8 the F function. Okay, now again, the thing to be careful of here is that the G bounds start at 3 because that's when they began being replenished, was at time 3. So a little bit of a tricky setup here, okay? But if you can do that, that's good for a point. It's actually good for 2 points, your setup, and then carefully punching things in will get you the last point. So you would sub 50 in for the amount at time 0, and then again carefully go through using your Math 9 feature to set up these integrals on the calculator. And what you should get back is that at time 8 we have approximately 23.347 pounds of bananas remaining on the display table. All right, so that was a tough problem. We'll take a look at the others in the coming days. But study this stuff, practice it, pause as you need to, take notes, write it down, play along on your calculator. As of now, we're still looking to get that college credit, so let's be working for it, okay, folks? Talk to you soon.